All right, let's jump right in. We're going to talk about something that trips up almost everyone when they first start algebra, combining like terms. But here's the thing, we're going to look at it a little differently. We'll see it as a kind of brain trick, one that you can totally learn to beat. So let's get into it. Okay, so what is this algebra brain trick? Well, it's this funny idea that our own brains, while they're trying to be helpful, can actually point us in the completely wrong direction when we first see an algebra problem. It's a super common hurdle, but trust me, once you see what's going on, you'll never be able to unsee it. So why does a problem like this one, 3x plus 4y plus x, seem so confusing at first glance? I mean, if you look at that and feel a little lost with all those letters and numbers just jumbled together, you are definitely not alone. Our brain sees that mess, and its first instinct is to just simplify it, mash it all together as fast as possible. And that's exactly where the mistake happens. And here it is. This is the core of the problem. Your brain is basically hardwired to see things on the surface. It sees letters, it sees an X here and an X there, and it latches onto that. What it doesn't automatically see is the deep mathematical structure, the actual rules of the game. That's the trick we need to learn how to outsmart.
So the secret to beating this trick, it all comes down to a really simple but super powerful idea, like terms. Basically, in algebra, you can only combine things that are the same type of thing. It's just like in real life, right? You can't add 3 apples and 2 oranges and say you have 5 apple oranges. It just doesn't work. They're different things.
Okay, that makes sense. But how do we know for sure what counts as the same type in algebra? Well, it's not just a gut feeling. There are actually some very strict rules. Let's break down exactly what we need to look for. And here they are. It's a really simple 2-part test. That's it. First, the terms have to have the exact same variable, the same letter. Second, they have to have the exact same exponent or power. If you can say yes to both of those questions, boom, you've got like terms. If even one of them is a no, you have to leave them separate. So, if you take one thing away, let it be this little mantra. Seriously, burn this into your brain. Anytime you feel stuck, just say it to yourself. Same letter, same power, same type. That is your new secret weapon for seeing the real structure of the problem and totally ignoring that brain trick. All right, theory's great, but let's put this into practice. We're going to look at the wrong way versus the right way. We'll take our original problem and see what happens when you fall for the brain trick and what happens when you use our new rule. So let's look at our problem again. 3x plus 4y plus x. Now, let's really see what happens when we compare these two ways of thinking. And wow, this really shows the difference, doesn't it? On the left, that's the brain trick in action. It's like throwing everything into a blender and just mashing it all together to get something like 8xy, which is completely wrong. But on the right, that's the structural way. That's what happens when you follow the rules. Now we're going to walk through how we get to that correct answer, 4x plus 4y, but just look at how totally different those two answers are. So how do we get there? Let's walk through it the right way, step by step. First, we identify our like terms. We scan through and look for the same letter, same power. And there they are, 3x and x. Step 2 is a big one. Remember the invisible 1. That lonely x on its own isn't just x, it's really 1x. That 1 is just invisible. So for step 3, we combine the numbers, the coefficients of our like terms. We take the 3 from the 3x and the 1 from the 1x, and we add them together. 3 plus 1 gives us 4x. Okay, so what about that 4y? Well, that's step 4. It doesn't have a partner. It's an unlike term, so we just keep it separate. And that leaves us with our final correct answer in step 5, 4x plus 4y. See? It's just a clean, logical process. Now, you might be thinking, okay, I get it for this one type of problem, but why does this skill matter so much? Well, let me tell you, this isn't just some random rule you have to memorize for a test. This is one of the absolute foundational building blocks for pretty much everything else you're going to do in algebra. I mean, look at this. Mastering this is critical for everything that comes next. Think about using the distributive property, or solving equations, or working with these big things called polynomials, or factoring. All of that advanced stuff, it all rests on your ability to confidently combine like terms. If that foundation is shaky, the whole thing just falls apart. This one skill is basically your ticket to understanding the rest of algebra. So let's reframe this whole thing. This isn't just about learning a rule to avoid getting a question wrong. When you learn to see the structure of a problem like this, you're basically unlocking your new math superpower. And this is really the big idea here.
Once you train your brain to stop seeing just a jumble of letters and numbers, and you start seeing the actual structure underneath, everything changes. Algebra stops being this frustrating, confusing thing, and it turns into a kind of puzzle, a puzzle that you actually know how to solve. And that kind of leaves us with one last question to think about. This whole idea of ignoring the surface level noise to see the deeper structure, that doesn't just apply to math, does it? Now that you know how to beat this one little brain trick, what other brain tricks out there in learning or maybe even in life are you ready to overcome?